Assalamualaikum and good day to everyone. Today I'm Siti Roslinda. We'll share with you the topic 3.3 hypothesis testing for the difference between two population means. In this topic, we divide it by two. The first one is independent samples and the second one is dependent samples. As for now, we will go to the first part, that is independent samples. For this part, parameter is known as mu1 minus mu2. As usual, there are three types of tests: two-tail test, right-tail test, and left-tail test. And mu0 here is known as hypothesis mean difference, which can take any real value. There are 5 formula of test statistic for mu1 minus mu2, as you can see on this slide. The procedure to choose the right formula is the same as given in chapter 2 under the same parameter, that is mu1 minus mu2.
So now we go to example 3.3. Okay, I know the solution is already given to you. Okay, however, I want to show you the idea behind the solution. Okay, so now we look at the claim given, the claim that we need to test. So by looking at the question, you can see that this is the claim. Okay, note that for your module there is no alpha is given, is it? So just delete this one. It's okay. So so look at the claim given. Okay, can we say that both branches of wall have similar average overall distance? The keyword here is average. Average is the same as mean. So for the average, the notation here should be mu, because claim must be for parameter, and here there are two branches and the relationship between them is similar, so means that this is mu1 equal to mu2. And since this case we can see that the parameter here, the parameter used here is mu1 and mu2, means that this is under difference between two means. For the difference between two means, we need to be careful with the theta used. Either this is under mu1 minus mu2 or mu d. Okay, mu d is dependent sample. Mu1 minus mu2, that is under independent sample. We can identify the theta here by looking at the information given. Okay, look at the data set for brand 1 and brand 2. We can see that there is no relationship between these two data sets. So, means that the data are independent to each other. So, we need to use mu1 minus mu2. So, means that this is under independent samples. So, for this case, to the form for theta is mu1 minus mu2, so we need to transfer mu2 to the left side. So the new form for this claim will be mu1 minus mu2 equals to 0, and this is the claim. So for the claim, after we identify the claim, the next step is, okay, construct the hypothesis. This is in step 1. To construct the hypothesis, look at the expression used. This is equal, meaning that this is hash null. Okay, so construct H1. Automatically we can construct H1. This is mu1 minus mu2. The theta is the same, mu1 minus mu2 equals to, meaning that this is should be not equals to 0. Mu0 still the same, 0, 0. Okay, so complete step 1. So now go to step 2. Okay, step 2 is to identify to calculate the test statistic. So the theta used here is mu1 minus mu2. So the test statistic here, okay, that we need to consider are given here. There are 5 formula. Okay, so we the information given by the question will help us to identify the appropriate test statistic for the question. So from brand 1 dataset, we can summarize this data, okay, by using the notation, okay. Since this is sample data set, we can look at the question. 10 balls selected randomly, means that this is sample. Okay, means that this is N1 equals to 10. By using calculator, we can get X bar 1 and S1. Okay, the same for brand 2. So you can use here, this is N2. The number of data is also 10. X bar 2 and S2. Okay, we can get X bar 1 and we can get X bar and S by using calculator. The next information given, that is about the assumption of the equality of the population variance. Okay, it's clear this is different, meaning that this is sigma 1 squared not equals to sigma 2 squared. So now, by using the information given, we can choose the formula. You can see that for that case, sigma 1 squared and sigma 2 squared unknown. Unknown here because of when we look at the information given, there is no value for sigma 1 squared and sigma 2 squared. So that's why, okay, so this is under sigma 1 squared and sigma 2 squared unknown. When unknown, then look at the assumption for equality of the variances. Okay, the equality of the variances for this case, that is sigma 1 squared equals to sigma 2 squared. Okay, and then the next one, that is the number of data. When we look at the number of data, okay, and 110 and 210 both less than 30. Okay, so means that here, so we can see that the formula that we need to choose, that is formula number 5. So calculate the t-test by using formula number 5. So this is already given in your solution. Just calculate the formula and simplify the answer at 4 decimal places. Okay, so now complete step 2. Okay, so now we go to step 3. Step 3 is we want to establish the test criterion. Okay, so the test criterion that depends on 3 factors. The first factor, that is the distribution used. The distribution used here is t-test. T-test means t distribution. So you need to plot t distribution. Okay, and then the second factor, that is inequality used in H1. The inequality used here is not equals to. When not equals to, meaning that there are 2 rejection regions here. So that's why we need to shade the rejection region that lies on the left tail and right tail of the t distribution, meaning that for this case we have 2 critical values. Okay, and then the third factor that we need to consider is alpha. When we look at the question, okay, alpha is not given. When alpha is not given, so we need to assume, okay, alpha is equal to 0.05. We use the standard alpha. Okay, so that's why alpha used here is 0.05. And then since alpha, the test is 2-tailed test, okay, so we need divide our alpha by 2. Okay, so for the t distribution, we need to consider the degrees of freedom no. So when we look at the formula given, okay, the t-test used is formula number 5. So for the formula number 5, the degrees of freedom that we need to use is by using this formula. So you calculate the no formula, calculate the no value here. So we and then round down the value of no. So we can get the value of no now is 17. Okay, so by using statistical table, get the value for t 0.025 with a degrees of freedom 17. So we get the value 2.1095. 8. So now we have so now put the value of minus t 0.025 with a decrease of freedom 17, another one t 0.025 with a decrease of freedom 17. Okay, so now complete step 3. Step 3, we can identify rejection region and critical values. So now we go to step 4. Step 4, we want to make a rejection, we want to make a decision on H null. Okay, so look at the to make a decision. Okay, we need to compare t-test and the t-critical value. Okay, the value of t-test here 2.5061. Okay, identify the value of t-test here either the value is under a rejection region or acceptance region. So we can see that 2.5 here is lies on this area, and then you need to write this in a proper form. So t-test here is greater than this t-critical value. So write this, and then since this is lies on the rejection region, so that's why we reject H null. And the last step, okay, step 5, that is a conclusion for the claim. So reject H null, reject H null. Okay, meaning that in this case reject H null, this is the same as we reject the claim. So that's why at alpha 0.05 there is sufficient evidence, that's because of reject H null, so sufficient evidence. And here we reject H null, at the same time we reject the claim. Okay, so that's why sufficient evidence to reject the claim. Okay, okay, so now complete the solution for example 3.3. So now we look at example 3.4. I know the complete solution is already given to you. However, for this one, I want to show you or to share with you the working behind the solution. So we start with the claim. Claim here, that is about mean. So mean denoted by mu. Mean of alloy 1, mu 1 exceeds. Okay. Means that the expression u is greater than mean of alloy 2, that is mu 2, more than, that is greater than the value given 0.5, and this is the claim. Okay, by looking at the claim we can see that there are two maths expression here or two inequality given here, so we need to choose the right one. Okay, the right one, that must be the closest to the mu naught. Okay, in this case mu naught is 0.5 because mu naught is a value. So means that this is the right max expression or inequality for this claim. So for this one we need to replace with minus. Okay, for this one we need to replace with minus. Okay, and then this is the claim for this question. mu1 minus mu2 greater than 0.5. Okay, after that construct the hypothesis. Okay, step 1, construct the hypothesis. So you can see that when we want to construct the hypothesis, okay, look at the inequality used here, the max expression used here, that is greater than. So since this is greater than, no equals to here, so that's why this is H1. Okay, automatically we can construct H null. H null for this case, that is mu1 minus mu2 less than and equals to 0.5. So complete step 1. So we will go to step 2 to calculate the test statistic. So to help us to choose the right test statistic, we can look at the information given. The first one, that is the data summary here. The data given here, you can see this is a data summary and this is very clear. sample. Since this is sample, means that mean here is referred to sample mean. Okay, so the notation used is X bar. Standard deviation, that is S. Number of data, that is N. Okay, and then the other information given, that is assumption on the equality of the population variance. You can see that, okay, from this sentence, means that this is tell us that sigma 1 squared equals to sigma 2 squared. Okay, so now it's time for us to choose the right test statistics. So we can see that population variance unknown. There is no value for sigma 1 squared, sigma 2 squared. Okay, so this case is unknown. After that, we need to look at the population equality of the population variances. This is equal, so you need to use the formula of SP. So calculate SP here. So that's why when you look at step 2, you need to calculate SP first. Okay, simplify your value of SP at 4 decimal places. Okay, the next step is look at the sample size. Okay, both sample size are large, so that's why you need to use z-test. Okay, and then apply the formula for z-test. Okay, and then simplify your answer at 4 decimal places. Step 3, step 4, step 5 as usual.